Okay, this is a follow-up to my earlier video from tonight. I'm making these aluminum rack panels on a CNC router for a power distro. So I've got some circuit breakers and outlets and different components that have to be mounted. And so I was going to fabricate a box out of aluminum entirely, and then I found on a Google search pro speaker parts, I think, company.com maybe. They had these panels that were powder coated black, and they are a part of a rack mount unit that's 2U. So I decided to just cut the profile into them directly instead of fabricating my own box. So I had set up some of the cuts, and I test cut one out of 3mm birch just to see that my parts were going to fit, and I made a few adjustments. And then I set up a couple of test cuts, and this one right here, I ended up breaking my bit for traveling too fast, I believe, and I also didn't have a coolant. So then I was kind of desperate because I only had one bit, and it was a straight flute instead of a single flute, a Mana single flute mirror polish cutter here. This was the cutter that I was trying to use in 1/8 inch, but it turns out that my collet had a burr inside of it, and that burr split the tool while I was cutting. It didn't fail at the cutter. It failed up inside the collet because of the burr. So I switched to 1/4 inch on this tool in order to prevent that in the future. And I also got a fresh 1/4 inch collet just to be safe. So I did these test cuts here with that smaller tool earlier, but they required this cleanup. As you can see, that's not going to work out. So I got some more tools, and I set up on the router. And if you've never cut aluminum on your router, just be sure you're ready for it, because it makes a real big mess. As you can see, some of the cooling fluid got on my spoil board down here, and it's going to swell up. Possibly, I may have to cut that one again. But I put this piece of drop on top of it to prevent it from soaking into my larger spoil board. So this was my setup. I clamped it down. I shot these blocks to this piece of drop wasteboard, and then I screwed the brackets directly to them, and then my work pieces were able to fall out the bottom. Although I didn't penetrate far enough, and it kind of chipped up the paint on the back, which is probably okay. I used this soluble oil lubricant. I got it on Amazon. It wasn't anything special. And again, on Amazon, I got this spray lube tool here. It's just a magnet. And I stuck it on the router. This one is really great. I got a cheap $10 one before this, and it didn't work out of the box. So, and I just used a bottle down here to hold the fluid mix. I basically put maybe a quart of water in the bottle, and then I poured the oil in until I just felt satisfied, which was, I don't know what the ratio was, but it seemed to work great. It kept the bit really cool. When I was cutting the test piece, it was throwing the drop out, and I didn't really like that. So I tried to set it up so it would fall away. You can see the single flute cutter here. I had a hard time trying to figure out how best to set up this cut. My particular router, it's not real easy to adjust this RPM of the spindle, so I was working at full speed, which is 18,000 RPMs, and I set up the cut to do a 0.5 millimeter depth of cut per pass, and I set up a 2-degree ramp in Fusion, of course, and I used the Amana 51373 1/8-inch cutter, and of course you can see I cut these for 515 duplex outlets, and then these are the single round. I don't know what their size is. The National Association of Electrical Manufacturers seems to keep that stuff secret. I also had one oops here. As you can see, my cutter dug in there. I had actually had this set up like this, and the cutter came in to make this hole, and I never re-zeroed after this thin test piece that I had cut successfully, and so it plunged right through the piece and tried to start cutting down below here. So I was able to stop that cut and then flip it over, and this flanged receptacle here is just going to cover that there, no problem. So it'll be a little error on the backside, but it shouldn't affect the final product. Yeah, so that's pretty much it. I can, sorry, I know this is pretty low class, my cell phone in the shop in the middle of the night, but that's what I got. So basically, I just set up these sketches, and I made an outlet. I couldn't find the dimensions of the outlet, like the standard US plug, basically. So I had to make it up with just a caliper, and it got pretty close, and I had to make a little adjustment to it. But as you can see here, this is the outline of where the circuit breaker goes, and I just did that layout. And then I did a lot of copy pasting. This is also a PowerCon D-size connector. Those dimensions were available online, which was really great. And the circuit breaker dimensions from Square D, it's a QOU style circuit breaker that is panel mountable, and it has reversible lugs, which is super great. So this is just a 3-phase 30 amp L2130 feed for this distro. It's just going to go in an amp rack. So L2130 3-phase in, and 240 volts out for amplifiers, and some power cons for some little stage boxes and stuff. And again, circuit breakers for all those different things. And I guess it's going to go in this rack here. Yeah, right there. So I'll have another K10 here, and then the 2 U's of a distro here, and then 2 more amps above it, and they'll all share power. So there you go. Hope that's enjoyable. And if you're trying to cut aluminum in the shop in the middle of the night on the router, and you need some speeds and feeds, this has worked for me. I'm not sure if it'll work for everybody. I'm sure you could also go faster with this tool, probably, but I had such a rough start that I didn't want to break any more tools. So I appreciate your time. Sorry I'm rambling, but this is how it is late at night in the shop. So thanks. Bye-bye.